Hello, and welcome to Boring Science to Sleep, a quiet place where science becomes slow, soft, and easy to drift through. Tonight, we're going to gently explore the strangest corners of the universe, not to understand every mystery, but simply to notice them, slowly and peacefully. Before you settle in, if you enjoy these calm journeys through science, you're always welcome to like this video and subscribe, only if it feels right for you. And if you'd like, let me know in the comments where you're listening from and what time it is where you are. It's always a quiet joy to imagine so many people in so many different places sharing the same peaceful night beneath the stars. Now, dim the lights if you can, get comfortable, and let your breathing slow just a little. There is nowhere you need to be, nothing you need to solve. Tonight, the universe will quietly tell the story for you. So simply close your eyes, listen, and drift gently into the vastness of space. For almost your entire life, the ground beneath your feet has felt permanent. The sky has stretched above you every morning, every evening, changing its colours with quiet patience, while the stars waited for darkness to return. They have always seemed distant, almost decorative, like tiny lights carefully stitched into an enormous curtain that hangs above the world. Yet tonight, without taking a single step, you can allow yourself to imagine something different. Imagine that Earth slowly becomes smaller beneath you, not quickly, not dramatically, just slowly enough that you hardly notice the movement. The continents soften into gentle shapes, the oceans blend into a deep blue sphere, and the clouds drift lazily across its surface, just as they always have, unaware that you are quietly floating farther away. You are safe. There is nothing to hold on to, nothing to chase. The universe asks nothing of you except your attention, and even that can be wonderfully gentle. As Earth becomes a glowing marble behind you, another thought quietly appears. If one small world like this can exist, could there be others? For thousands of years, people wondered whether our home was unique. Ancient storytellers looked toward the stars and imagined distant kingdoms, celestial gardens, or quiet spirits living among the lights above. Long before telescopes existed, curiosity had already begun its slow journey across the night sky. Today, science asks the very same question. Only now, instead of myths, we have delicate instruments, patient observations, and decades of careful listening. And the answer, surprisingly, seems to be whispering back. Perhaps worlds are everywhere. Our own galaxy, the Milky Way, is difficult to imagine because the numbers become so large that they almost lose their meaning. Rather than trying to picture impossible figures, it may help to imagine standing beside a quiet beach at sunrise. You reach down and pick up a single grain of sand. It feels tiny between your fingers. Now imagine every grain across that entire shoreline becoming a star. Even then, the real number of stars inside our galaxy stretches beyond comfortable imagination, filling space with quiet suns scattered across distances so vast that light itself spends years, centuries, even thousands of years travelling between them. For a very long time, no one knew whether those distant stars had companions. Perhaps our solar system was unusual. Perhaps planets were rare. Perhaps Earth had been lucky in a way the universe never repeated. Then, little by little, the discoveries began. Astronomers noticed tiny changes in starlight. Not dramatic changes, not bright flashes, only the smallest flickers, so gentle that they could easily have been mistaken for nothing at all. Imagine watching a lantern glowing across a quiet lake at night. For just a moment, a tiny bird drifts across the light. The lantern does not disappear. It simply becomes ever so slightly dimmer before shining brightly once again. That delicate shadow tells you that something passed in front of it. Astronomers watch stars with the same quiet patience. Sometimes an unseen world crosses its star from our point of view, creating a tiny dip in brightness. That almost invisible shadow becomes a whisper saying, "There is a planet here." Other times the star itself seems to sway almost imperceptibly, as though gently dancing with an unseen partner. The planet is too small to see directly, but its gravity gives the star the slightest tug, revealing a hidden companion through an elegant cosmic dance. These discoveries did not arrive all at once. They arrived slowly. One distant world, then another, then dozens, hundreds, thousands. And with every new discovery, something remarkable became clearer. Planets are not unusual. They appear to be one of the universe's favourite creations. Some circle small, cool stars that glow softly for trillions of years. Others orbit brilliant blue giants that live only brief cosmic lives before disappearing. Some travel alone. Some belong to families of many worlds, moving together in graceful harmony around their stars. Every discovery quietly expands the map of possibility. Naturally, another question begins to emerge. Among all these countless worlds, which ones resemble home? Scientists have created a gentle way of thinking about this question. Rather than asking whether another planet is exactly like Earth, they simply ask how closely it resembles the place we already know. Does it appear to be similar in size? Could gravity feel familiar? Might temperatures allow liquid water to exist? Could an atmosphere protect its surface? Each answer becomes one small piece of a larger picture, rather like comparing leaves from different trees or seashells collected from distant shores. No single detail tells the whole story, but together they begin to suggest whether a world might feel strangely familiar. This quiet comparison is known as the Earth Similarity Index. Despite its formal name, it is not a promise. It is only a gentle conversation between astronomers and the universe. A way of saying, this world reminds us just a little of home. Another peaceful idea often follows. Imagine sitting beside a campfire on a cool evening. Move too close, and the heat becomes overwhelming. Step too far away, and the warmth fades into cold darkness. Somewhere in between lies a comfortable place where you can simply sit, breathe, and watch the flames dance. Many planets travel through a similar region around their stars, not too warm, not too cold. Astronomers call this the habitable zone, though you can simply imagine it as the gentle circle where conditions may allow water to remain quietly liquid, instead of freezing solid or disappearing into invisible vapour. Of course, even this peaceful neighbourhood offers no guarantees. A world may sit in exactly the right place and still become a frozen desert. Another may possess thick clouds that trap enormous amounts of heat. Some planets spin so slowly that one side always faces their star, while the other remains wrapped in endless night. The universe, it seems, enjoys writing stories far more imaginative than our expectations. And perhaps that is what makes it so comforting. Every answer uncovers another question. Every discovery opens another quiet doorway. Somewhere beyond the familiar warmth of Earth, beyond the countless ordinary worlds that gently circle distant stars, there are places where oceans may stretch deeper than mountains, where rain may fall unlike anything ever seen beneath our own skies, and where lonely planets wander through darkness with no sun at all to guide them. Those remarkable places are waiting patiently, not asking to be conquered, only to be noticed. And as your thoughts drift farther from home, another distant world begins to emerge from the darkness, carrying a story even stranger than the last. After drifting away from Earth, your eyes slowly begin to adjust to the enormous darkness around you. At first, space appears almost empty. Not because nothing is there, but because everything is separated by such astonishing distances that silence becomes the most natural language of the universe. Then, one by one, distant stars begin to appear. Some glow softly with warm golden light. Others shimmer with cooler shades, almost blue against the endless black. Each of them is a sun. Each of them may have its own family of worlds quietly circling through space, just as Earth circles our own sun. For a moment, Imagine standing on the shore of an endless ocean at night. Thousands of tiny boats carry lanterns across the water. You cannot see the boats themselves, only the gentle lights floating in the darkness. Now imagine that every one of those lights may have its own hidden shoreline, its own skies, its own weather, perhaps even its own oceans. The thought feels almost unbelievable. And yet, with every passing year, astronomers continue to discover that planets seem to be wonderfully common. The great surprise is no longer that planets exist. The surprise is how many of them seem to resemble places we already know. One of the first worlds to quietly capture people's imagination was a distant planet known as Kepler 186f. Its name may sound technical, but you don't need to remember it. Instead, simply imagine a quiet world circling a small, gentle red star, hundreds of light years away from Earth. It became famous because it was one of the earliest planets discovered within the comfortable region around its star where temperatures might allow liquid water to exist. No one knows what its surface truly looks like. Perhaps it is covered with oceans, perhaps endless deserts, perhaps thick forests unlike anything our own world has ever seen. Or perhaps it is completely barren. The universe keeps some of its secrets remarkably well. Still, just knowing that such a place exists quietly changes something inside the imagination. Earth is no longer the only possibility. Not far away, at least by the standards of our galaxy, another remarkable world circles the closest star to our own sun. Astronomers call it Proxima Centauri b, though you can simply think of it as our nearest neighbouring world. If you could travel there, the journey would still take far longer than a human lifetime with today's technology. Distance, even between neighbours in space, is measured with extraordinary patience. This nearby world may be rocky. It may have mountains. It may even have valleys shaped by ancient geological forces. Yet living close to a small red star brings its own quiet challenges. Red stars are calm for long periods, but every so often they release powerful bursts of energy, rather like a peaceful campfire that suddenly sends sparks dancing high into the air. Those energetic outbursts may strip away an atmosphere over millions of years. Without a protective blanket of air, even a promising world can become cold, dry, and silent. A planet's story is never written by distance alone. Many pieces must come together: size, gravity, air, water, a magnetic shield quietly protecting the surface from invisible streams of energetic particles. Like instruments in an orchestra, each part contributes to the music. Remove one, and the melody changes. Among the most fascinating discoveries is a family of 7 rocky planets quietly orbiting a single small star. Together they are known as the TRAPPIST-1 system. Rather than imagining complicated orbital diagrams, picture 7 smooth stones gently circling a candle placed in the middle of a dark room. Each stone follows its own steady path. Some travel closer to the warmth, others remain a little farther away. Several appear to lie within that comfortable region, where water could remain liquid under the right conditions. No one knows whether oceans truly exist there, but imagining 7 neighbouring worlds sharing one tiny star feels strangely comforting, almost like a quiet little village hidden somewhere within the vastness of the galaxy. Another peaceful discovery arrived when astronomers found TOI 700d, a planet that circles its star with calm regularity. Unlike some more violent stellar systems, this one appears relatively gentle. Scientists believe it may receive an amount of warmth somewhat similar to what Earth receives from the Sun. Again, this does not guarantee life. It does not even guarantee oceans. But it reminds us that nature seems remarkably willing to create places that, at least from afar, appear quietly familiar. Still another intriguing system belongs to a tiny dim star known as Teegarden Star. Its planets are among the most promising Earth-sized worlds discovered so far. Their star shines so softly that daylight there would likely feel very different from the bright afternoons we know. Imagine standing beneath a sky where the sunlight never becomes dazzling. The landscape would glow with gentle amber colours, and long shadows might stretch peacefully across quiet plains. Perhaps sunsets would last much longer. Perhaps mornings would arrive almost unnoticed. The universe enjoys offering endless variations on familiar themes. As astronomers discover more of these distant worlds, it becomes tempting to ask a simple question. Which one is most like Earth? The honest answer is beautifully unsatisfying. No one knows. Every promising planet also carries unanswered questions. A world may have the perfect temperature but no atmosphere. Another may possess thick clouds that trap too much warmth. One may have abundant water but little dry land. Another may have continents without a single drop of rain. Some planets may always show the same face to their star, leaving one hemisphere bathed in endless daylight while the other remains beneath an eternal night. Yet even there, between the light and the darkness, there could exist a narrow band where gentle twilight never ends, a place where morning and evening become the same quiet moment, lasting forever. It is a beautiful reminder that the universe rarely copies. Instead, it creates endless variations. Earth is not a template repeated again and again. It is simply one melody within an immeasurably larger symphony. Perhaps somewhere, another world carries blue oceans beneath lavender skies. Perhaps gentle rain falls through orange clouds. Perhaps snow drifts across forests unlike any that have ever grown on Earth. Or perhaps those worlds remain completely silent, beautiful simply because they exist. For now, we can only wonder. And perhaps wondering is enough, because as those quiet planets continue their patient journeys around distant stars, somewhere farther out, the universe begins to reveal worlds that no one could ever mistake for home. Places where oceans may boil, rocks may flow like rivers, and rain itself becomes something almost unimaginable. The farther you drift into the darkness, the stranger the universe quietly becomes. If Earth feels like a familiar melody, then the next few worlds are entirely different songs. They follow the same laws of gravity. They circle distant stars just as faithfully as our own planet circles the sun, and yet almost everything else about them seems wonderfully unfamiliar. As you drift farther into the galaxy, imagine the comfortable blue oceans of Earth slowly fading behind you. The forests disappear. The rivers become distant memories. Even the clouds begin to feel like something from another lifetime. Ahead lies a collection of worlds where nature has chosen entirely different ways to shape a planet. The first appears almost peaceful from a distance, a smooth sphere quietly circling its star. No storms are visible, no continents can be seen, only a faint glow along one side. But as you slowly approach, you begin to understand why. This world travels so close to its star that its surface becomes unimaginably hot. Not simply a warm summer afternoon, not even the heat of a desert beneath the midday sun. Imagine standing beside a great river of molten rock flowing from the heart of a volcano. Now imagine that warmth stretching across an entire world. On planets like these, rocks do not always remain solid. Mountains may slowly soften. The ground itself can glow with heat. In some places, stone may behave almost like thick honey, flowing so slowly that centuries pass before anyone would notice the movement. It is a strange thought. On Earth, rivers are made of water. Elsewhere, a river may be made of glowing rock. The universe does not insist that every landscape follow familiar rules. Some of these distant planets are so close to their stars that they have become locked into a permanent rhythm. Imagine always showing the same side of your face to a campfire. One cheek would forever feel warm, the other would never receive the light. Many distant planets live exactly this way. One side faces endless daylight, the other remains beneath an eternal night. There is no sunrise, no sunset, no changing seasons. The sky never changes because the planet turns in perfect harmony with its journey around its star. At first, that sounds lonely. But nature rarely allows complete stillness. Between the brilliant daylight and the endless darkness lies a narrow region, where light never fully arrives, yet darkness never completely takes over. Imagine walking through an evening that never ends, a sky forever painted with the soft colours that appear just before nightfall, gentle shadows stretching across silent plains, neither morning nor midnight, simply an endless twilight. Some scientists believe these quiet boundary regions could be among the most comfortable places on such extraordinary worlds. Weather there would almost certainly be unlike anything we experience on Earth. Because one side of the planet is constantly heated while the other remains permanently cold, the atmosphere never truly rests. Warm, air slowly rises beneath the endless daylight. Cool air quietly sinks beneath the eternal night. Together they create enormous rivers of moving air that circle the planet again and again. Imagine standing beside the ocean as a steady breeze brushes gently across your face. Now imagine that breeze becoming so powerful that it circles an entire planet without ever stopping. Even something as familiar as wind becomes a completely different experience. Some distant worlds have skies filled with clouds, but these are not the soft white clouds drifting above peaceful fields on Earth. The materials floating through their atmospheres are entirely different. Instead of tiny droplets of water, the clouds may be made from minerals that have risen into the air because the temperatures are so extreme. As those materials cool, they slowly fall once again. It is tempting to call it rain, but it is unlike any rain you've ever known. Imagine tiny grains of glass forming high above the landscape. Driven sideways by powerful winds, they sweep through the atmosphere like shimmering curtains catching the light. Elsewhere, clouds may release droplets of molten metal instead of water, not because the universe wishes to be dramatic, simply because under different conditions, different materials become liquid. Nature quietly follows its own rules. Wherever those rules lead, extraordinary landscapes appear. One particularly mysterious planet reflects almost no light at all. It is darker than fresh charcoal, darker than a moonless night. If you were somehow able to float nearby, it would seem less like a world and more like an opening into empty space. Not because it is a hole, but because its atmosphere absorbs nearly all the light that reaches it. Only the faint outline of its star reminds you that something enormous is quietly waiting in the darkness. Even colours themselves become uncertain. When we imagine planets, we often picture blue oceans, green forests, or red deserts. But most distant worlds remain invisible to our eyes. The colours shown in books and documentaries are often careful artistic interpretations, helping us imagine places we cannot yet see directly. The real universe may be even more subtle, or perhaps even stranger. One day, future generations may look upon photographs of these worlds with the same familiarity that we now look upon images of Earth. For now, imagination gently fills the spaces where certainty has not yet arrived. Perhaps the most comforting realization is that none of these extraordinary planets are mistakes. They are not accidents. They are simply different answers to the same quiet question. What happens when gravity gathers dust, gas, rock, and time together? Sometimes the answer becomes Earth. Sometimes it becomes a frozen desert beneath a dim red sun. Sometimes it becomes an endless ocean stretching hundreds of miles deep. Sometimes it becomes a glowing landscape where rivers of molten stone slowly wind across the surface. The universe seems endlessly creative. It rarely repeats itself exactly. Instead, it composes quiet variations, each world carrying its own gentle personality, shaped by distance, warmth, gravity, and time. And as remarkable as these planets may seem, every one of them still has something in common. Each belongs to a star. Each remains connected to a warm source of light somewhere nearby. But not every planet is so fortunate. Far beyond these extraordinary worlds, there are others that have lost even that final companion. They travel alone through the endless darkness, with no sunrise to greet them, no sunset to mark the passing of time, and no star waiting on their horizon. Even in the silence of interstellar space, they continue their patient journey, almost invisible, almost forgotten, yet quietly carrying some of the universe's most beautiful mysteries. By now, you have drifted past worlds wrapped in glowing lava, planets where endless twilight stretches across the horizon, and distant landscapes shaped by weather unlike anything Earth has ever known. Yet every one of those remarkable places still shared something familiar. Each belonged to a star. Some circled close, others wandered farther away, but every sunrise, every shadow, every gentle breeze still traced its origins back to a nearby sun. Now, imagine letting that final source of light slowly disappear behind you. At first, nothing seems different. The stars still fill the distance. The galaxy still stretches like a pale river across the darkness, but the world beside you has no sunrise waiting ahead, no warm daylight, no evening glow, no seasons quietly following one another through the years. This planet belongs to no one. It travels alone. Astronomers call these wandering bodies rogue planets, although the name sounds much more dramatic than their quiet lives truly are. You might instead imagine them as travellers, silent islands floating through an endless cosmic sea. No anchor, no harbour, only an unimaginably long journey through the darkness between stars. It seems almost impossible. How could an entire planet lose its sun? The answer begins long before the planet ever becomes lonely. Every planetary system is born inside enormous clouds of gas and dust. Over millions of years, gravity patiently gathers tiny grains together. Pebbles become rocks, rocks become mountains, mountains become worlds. For a time, everything appears calm. Young planets settle into graceful paths around their newborn star, each following its own quiet rhythm. But the early years of a planetary system are not always peaceful. Imagine several children trying to dance across a small stage at the same time. Each movement gently influences the others. A single unexpected step may change the entire performance. Planets behave in much the same way. Their gravity constantly whispers to one another. Usually those whispers remain gentle. Sometimes, however, they slowly build into something much larger. A close encounter, a powerful tug, a gradual shift that continues for thousands, or even millions of years. Eventually, one planet may be nudged farther and farther away. Its path grows wider, its journey becomes less stable. Then, one quiet day in cosmic history, it simply keeps going, never returning. The star grows smaller behind it. The warmth fades, and the planet begins a journey that may continue for billions of years. Not because anything exploded, not because the universe became violent, simply because gravity quietly rearranged the dance. The remarkable thing is that these lonely travellers are extraordinarily difficult to find. After all, planets usually reveal themselves because they borrow light from their stars. Without a nearby sun, a rogue planet becomes almost invisible. It reflects almost nothing. It shines only with the faint warmth left over from its own long history. Finding one is rather like trying to notice a single drifting snowflake during a moonless night. Yet the universe occasionally offers a little help. Imagine watching a distant lantern glowing across a dark valley. Now imagine someone silently walking in front of it. For a brief moment, the light bends ever so slightly around the traveller before returning to normal. The traveller remains hidden, but the changing light quietly reveals that something has passed by. Astronomers use a similar idea when searching for wandering planets. When one of these invisible worlds drifts between us and a faraway star, its gravity gently bends the starlight for a short time. The star appears to brighten in a very particular way before returning to its usual appearance. The planet itself may remain unseen. Its gravity becomes the only introduction it ever offers. Other lonely worlds are discovered in an even gentler way. Everything that exists carries a little warmth. Even a cup of tea left on a table slowly gives away its heat. A sleeping cat curled beside a window quietly radiates warmth into the room. Planets do the same. Although they no longer receive energy from a nearby sun, some still release the ancient warmth stored deep inside them. Powerful space telescopes designed to sense heat rather than visible light have detected a handful of these faint wanderers, glowing ever so softly against the darkness. The discoveries raise a wonderfully unexpected question. Could such a lonely world still be alive in some quiet way? At first the answer seems obvious. Without sunlight, surely nothing could survive. After all, nearly every living thing on Earth ultimately depends upon the energy of the sun. But Earth quietly reminds us that sunlight is not the only source of warmth. Far beneath the oceans, hidden in complete darkness, our own planet contains places where hot water slowly rises from deep underground. Around these warm springs, entire communities of living creatures flourish without ever seeing daylight. They live because the planet itself still carries warmth within. Perhaps a wandering planet could do something similar. Imagine an enormous ocean buried beneath miles of ice. The surface remains frozen and silent. Above it stretches endless darkness. Yet far below, the planet's own interior continues releasing gentle warmth left over from its birth, along with heat produced as naturally occurring elements slowly change deep inside the rocks. That hidden warmth may keep pockets of liquid water quietly flowing beneath the frozen shell. No sunlight, no blue skies, only darkness and water. Some scientists have even wondered whether a very thick blanket of hydrogen gas could help such a planet hold on to its warmth for unimaginably long periods. Think of wrapping yourself in several heavy blankets on a cold winter night. The blankets do not create heat, they simply slow its escape. A dense atmosphere might quietly perform a similar task for an isolated world, allowing precious warmth to linger far longer than we might expect. No one knows whether life truly exists on such planets. Perhaps they're completely silent. Perhaps they shelter simple microscopic organisms hidden beneath ice, or perhaps they represent possibilities we have not yet learned how to imagine. The universe often reminds us that certainty arrives much more slowly than curiosity. As you continue drifting beside one of these lonely worlds, there is something unexpectedly peaceful about its journey. No sunrise marks the beginning of a day, no sunset marks its end. Time itself begins to lose its familiar rhythm. The stars remain almost unchanged for centuries. The galaxy slowly turns overhead. The planet simply continues forward, patient beyond comprehension. It asks for nothing. It hurries toward nothing. It simply travels. And perhaps there is something quietly comforting about that. Not every meaningful journey requires a destination. Some worlds spend billions of years crossing the darkness between stars, carrying only their silent history and the gentle warmth hidden deep inside. Far ahead, however, the darkness begins to soften, not because another wandering planet has appeared, but because countless distant stars are gathering together into glowing clouds where entirely new worlds are waiting to be born. There is something deeply familiar about water. Long before you ever learned what an ocean was, you probably heard its quiet rhythms, the gentle sound of rain against a window, a river moving over smooth stones, small waves meeting the shore again and again without ever becoming tired. Water has always felt like home. Perhaps that is why, whenever astronomers discover a new planet, one quiet question almost always follows. Could there be water? Not because water is rare in the universe. In truth, it appears to be remarkably common. But because water has an extraordinary habit of making places feel alive. As you continue your slow journey through the galaxy, imagine another world slowly appearing ahead. Unlike Earth, there are no continents waiting beneath the clouds, no mountain ranges, no deserts, no forests. only an endless ocean stretching in every direction. You drift lower. The waves move almost lazily beneath an unfamiliar sky. There is no shoreline, no distant island. Nothing interrupts the quiet surface. The entire planet is one immense sea. For generations, worlds like this belonged only to imagination. Today, astronomers believe they may truly exist. Some distant planets appear to contain far more water than Earth has ever possessed. Not merely larger oceans, entire worlds where water may shape nearly everything. If Earth were transformed into one of these places, every mountain would disappear beneath the waves, every valley, every plain. Even the tallest peaks would quietly vanish into the deep. Yet the deeper you travel, the stranger these oceans become. On Earth, if you dive beneath the surface, the pressure slowly increases. Your ears notice it. Your body feels it. The deeper you descend, the heavier the water becomes. Now imagine continuing downward, far beyond the deepest ocean trench on Earth, far beyond anything a submarine has ever reached. The pressure continues building with patient determination. Eventually, something remarkable happens. The water is squeezed so tightly that it changes into an unusual form of ice. Not because it has become cold, quite the opposite. It remains surrounded by warmth. Instead, the tremendous pressure gently persuades the water into arranging itself differently. Imagine snow that forms deep beneath a warm ocean rather than falling from a winter sky. It sounds almost impossible. Yet nature often chooses possibilities stranger than fiction. Scientists believe that beneath some distant oceans, enormous layers of this dense form of ice may quietly separate the liquid water above from the rocky interior below. If that is true, then these worlds possess entirely different relationships between sea and stone than Earth does. Their oceans are not simply larger, they are built differently from the inside out. Some ocean worlds may hold hundreds of times more water than our own planet. It is difficult to imagine such abundance. Picture every river, every lake, every glacier, every cloud, every ocean on Earth gathered together into a single drop. Now imagine repeating that again, and again, until entire planets become floating worlds of water. The universe seems wonderfully generous with one of life's simplest ingredients. But oceans alone do not guarantee calm weather. Imagine placing a kettle over a gentle flame. As the water warms, soft clouds of steam begin to rise. Now imagine a planet receiving far more warmth than Earth. Its oceans may slowly release vast quantities of water into the atmosphere. Clouds become thicker. The air grows heavier. The boundary between sea and sky begins to blur. Perhaps gentle rain falls almost continuously. Perhaps mist never completely disappears. Perhaps the horizon itself becomes soft and dreamlike, hidden behind layers of drifting vapour. On some worlds, the atmosphere may feel less like open air and more like walking through an endless warm cloud. Elsewhere, oceans may never appear on the surface at all. Instead, they remain hidden beneath thick shells of ice. This may sound lonely at first, but hidden oceans can be surprisingly active places. Even within our own solar system, several icy moons quietly encourage the imagination. One circles the giant planet Jupiter. Another journeys around Saturn. From far away they appear cold and silent. Bright spheres wrapped in frozen shells. Yet careful observations suggest something remarkable beneath that ice. Entire oceans of liquid water may quietly move through the darkness below. Imagine standing upon a frozen lake during winter. Everything around you seems perfectly still. Yet beneath your feet, unseen water continues its gentle motion. Currents drift. Tiny bubbles rise. The lake remains quietly alive beneath its blanket of ice. Some distant worlds, and even some nearby moons, may behave in much the same way. Deep below frozen surfaces, hidden seas may slowly circulate for millions of years. Warmth from the interior gently rises. Cooler water gradually sinks. Invisible currents complete journeys that no eye has ever witnessed. Could something live there? No one knows. Perhaps the darkness is completely empty. Or perhaps tiny organisms quietly drift through those unseen waters, never knowing what sunlight looks like. It is a strangely comforting thought. Life, if it exists, may not always need blue skies. Sometimes it may simply need patience. The more astronomers study water throughout the universe, the more they realize that Earth is only one expression of an idea that nature seems to enjoy repeating. Not copying, repeating differently. On one world, water becomes gentle rain. On another, it hides beneath mountains of ice. Elsewhere, it may stretch across an entire planet with no land in sight. Some oceans may be calm, others restless. Some may never meet the light of a nearby sun, yet all of them quietly remind us that the universe is capable of creating familiar things in wonderfully unfamiliar ways. Perhaps that is why the search for water has become, in many ways, a search for possibility itself. Every new ocean discovered, even one hidden beneath ice or buried beneath clouds, whispers the same quiet invitation. There is still more to find. There are still stories waiting beneath unseen waves, and while these distant seas continue their slow rhythm beneath unfamiliar skies, another kind of journey has already begun. Far away, patient eyes orbiting high above Earth continue watching thousands upon thousands of distant stars, searching for the smallest shadows, the faintest warmth, and the gentlest signals that reveal worlds we cannot yet see. Without those quiet observers, many of these extraordinary places would still be hidden in the darkness. Time equals quote 2.0 seconds quote / greater than long before a distant world receives a name. Long before anyone wonders whether it might hold oceans, mountains, or clouds. Someone first has to notice that it exists. That may sound obvious. But in a universe where even the nearest stars lie unimaginably far away, discovering a planet is rather like trying to notice a single drifting leaf floating across a lake while standing on the opposite shore. You're not close enough to see the leaf itself. Instead, you notice the smallest ripple, the faintest interruption, the tiniest clue that something has quietly passed by. That is how much of modern astronomy works, not through loud discoveries, but through extraordinary patience. Imagine lying on a hillside on a warm summer evening. Above you, thousands of stars quietly shine. If you looked for only a few minutes, every one of them would seem perfectly still. But imagine returning every night, for months, then years, watching the same tiny points of light again and again. Eventually you might notice that one star grows ever so slightly dimmer for a short time before returning to normal. Days later, it happens again, then again, always with the same gentle rhythm. That tiny change tells a story. Somewhere between you and that distant sun, a planet is quietly making another journey around its star. It never announces itself. It never flashes brightly. It simply passes by, leaving behind a shadow so delicate that only the most patient observer could ever notice it. For many years, one remarkable telescope spent its life doing almost exactly that. Rather than wandering across the entire sky, it quietly stared at one small region for years, watching more than 100,000 stars with almost unimaginable patience, night after night, month after month, year after year. It watched, not because anything exciting happened every day, but because extraordinary discoveries often arrive disguised as ordinary moments repeated many thousands of times. That telescope was called Kepler. Its mission was beautifully simple: watch, wait, notice. Kepler transformed astronomy in a surprisingly gentle way. Before its journey, planets around other stars were known, but they still felt uncommon. After years of careful observation, The picture quietly changed. Thousands of distant worlds began revealing themselves, some large, some small, some warmer than Earth, others colder, some circling tiny red stars, others travelling around brilliant suns much larger than our own. Perhaps the greatest discovery was not any single planet. It was the realization that planets appear almost everywhere. The galaxy was no longer filled only with stars. It was filled with neighborhoods, families, entire systems quietly moving together through the darkness. Eventually another quiet observer took its place. Rather than watching only one small piece of the sky, it slowly turned its attention toward almost every direction. Imagine standing inside a quiet library. Instead of reading one book from beginning to end, you gently walk from shelf to shelf, opening thousands of different stories, each for just long enough to discover whether something remarkable is waiting inside. This newer observatory follows a similar philosophy. It patiently surveys the sky, searching for nearby stars whose planets might someday deserve a closer look. Every discovery becomes an invitation for future exploration. Not the end of a story, only its beginning. Finding a planet is one thing. Understanding it is something else entirely. Imagine meeting someone standing far away on a foggy morning. You may recognize their outline. You may estimate their height. You might even guess the color of their clothing. But countless details remain hidden until you move closer. Astronomers face the same quiet challenge. Discovering a planet tells only part of its story. Learning about its atmosphere, its clouds, its temperature, its weather, requires an entirely different kind of observation. This is where another remarkable telescope enters our journey. Unlike earlier observatories that mostly gathered visible light, this one is especially skilled at sensing gentle warmth. Imagine entering a dark room. At first, everything seems invisible. Then someone hands you a special pair of glasses that allow you to notice warmth instead of brightness. Suddenly the room becomes full of quiet patterns. A sleeping cat glows softly beneath a chair. A cup of tea still carries warmth. Footprints remain faintly visible where someone walked only moments before. The room has not changed, only the way you observe it. The James Webb Space Telescope sees the universe in a similarly gentle way. Rather than relying only on visible light, it carefully observes longer wavelengths that reveal warmth hidden throughout the cosmos. This allows astronomers to study clouds surrounding distant planets, peer into enormous stellar nurseries wrapped in dust, and even look so far into space that they begin seeing galaxies as they appeared near the dawn of cosmic history. One of its earliest images quietly astonished the world. At first glance, it looked like a simple photograph filled with tiny points of light, but almost every point was not a star, it was an entire galaxy, each one containing countless stars of its own. Some were so distant that their light had spent billions of years crossing the universe before finally reaching the telescope's golden mirror. Imagine opening a letter that began its journey long before Earth had forests filled with birds, flowering meadows, or human footsteps. The message arrives unimaginably late, yet it arrives. Light possesses remarkable patience. It never hurries. It simply continues travelling until someone is finally waiting to receive it. Every telescope humanity builds becomes another pair of patient eyes. None of them travel to distant planets. None of them land upon strange worlds. They simply watch, quietly, carefully, faithfully, and somehow by collecting tiny pieces of light, they allow us to imagine rivers we have never seen, clouds we have never touched, and oceans stretching beneath skies no human being has ever stood beneath. There is something wonderfully humble about that. The universe does not easily surrender its secrets. Instead, it rewards patience. Every discovery begins with someone willing to spend years watching a single star. Every remarkable planet first appears as the smallest whisper of light. Perhaps that is why astronomy feels less like conquering the universe and more like learning to listen. As our quiet observers continue watching the stars, they reveal not only distant planets, but something even older, far beyond every familiar sun, beyond every planetary system. Vast glowing clouds patiently gather, preparing the next generation of stars long before their first light ever reaches the darkness. If you continue drifting beyond the lonely wandering planets, the darkness slowly begins to change. At first, it is almost impossible to notice. The empty spaces between the stars become ever so slightly brighter, not because a single star has appeared, but because the darkness itself has become softer. Ahead of you floats an enormous cloud. From far away it resembles morning mist stretching across a quiet valley. Its edges seem delicate. Its colours drift between soft blues, gentle purples, pale gold, and hints of rose, as though dawn itself has forgotten where to end. You move closer. The cloud does not hurry. Nothing here does. It simply floats through the galaxy with extraordinary patience. These immense clouds are among the quietest places in the universe. Astronomers sometimes call them giant molecular clouds, but you might simply think of them as cosmic nurseries, places where tomorrow's stars are still asleep. Imagine standing outside on a cool morning as a gentle fog settles across a field. The mist appears calm, yet within it countless tiny droplets quietly drift, gathering together before slowly falling back toward the earth. Something surprisingly similar happens inside these vast clouds. Tiny grains of dust, simple gases, countless invisible particles. Over millions of years, gravity gently encourages them to move ever so slightly closer together. No sudden rush, no dramatic collision. Only an almost invisible invitation. Come a little closer, then a little closer still. The cloud listens. Very slowly, small regions become just a little denser than the space around them. That tiny difference is enough. Gravity becomes ever so slightly stronger. More material quietly arrives. The growing pocket becomes heavier, then heavier still. The process repeats itself again and again, like gentle rain collecting into an almost motionless pond. Eventually, deep inside the cloud, something remarkable begins. A faint warmth appears, not visible at first, not bright enough to illuminate the surrounding mist, simply a quiet gathering of energy hidden beneath layers of dust. A young star is beginning its life. Astronomers call this early stage a protostar, but there is no need to imagine anything dramatic. Think instead of a tiny lantern slowly glowing beneath several thick blankets. The light exists, it simply has not yet found its way into the open. Around this newborn star, something equally beautiful begins to happen. Not all of the surrounding dust falls inward. Some of it gently settles into a broad, graceful disk that slowly circles the growing sun. Imagine stirring a spoon through a bowl of warm soup. Long after the spoon has stopped moving, tiny leaves and herbs continue circling in slow, graceful patterns. Nature often prefers circles, even on the largest scales. These quiet disks become workshops of possibility. Dust grains gently brush against one another. Some cling together, others separate again. Slowly, almost unimaginably slowly, tiny particles become pebbles. Pebbles become larger stones. The larger stones quietly invite still more material to join them. One day, after millions of years of patient gathering, entirely new worlds may emerge from these gentle circles of dust. Perhaps rocky planets, perhaps gas giants, perhaps oceans, perhaps mountains waiting for rain that has not yet fallen. Every planet begins somewhere remarkably humble, not as a finished world, but as countless tiny pieces learning to stay together. Some newborn stars are so energetic that they send narrow streams of glowing gas flowing away from their poles. These graceful streams travel across space, gently pushing through the surrounding cloud. When they meet colder gas, beautiful glowing patches quietly appear. Astronomers know these delicate structures as Herbig-Haro objects. The name sounds wonderfully technical. Yet the sight itself feels surprisingly peaceful. Imagine a quiet fountain in a garden at night. Water rises gently upward before meeting cool evening air, where it catches the soft glow of nearby lanterns. These distant streams behave in a similarly graceful way, painting quiet strokes of light across the darkness. Not every movement inside a stellar nursery is perfectly calm. Occasionally, young stars gather so closely together that gravity rearranges their surroundings in unexpected ways. Long ago, deep within the Orion Nebula, something appears to have disturbed a crowded family of newborn stars. Several streams of gas raced outward in different directions, leaving behind remarkable glowing trails. Today, astronomers sometimes refer to these as the Orion bullets. The name sounds energetic. But if you could watch the event unfold with your own eyes, it would seem astonishingly slow. Even these great streams would drift so gradually across the sky that generations of human lives might pass before noticeable change became visible. The universe remains patient, even during its most energetic moments. As you continue drifting, the cloud around you becomes even larger. This is the Orion Nebula, one of the nearest stellar nurseries to Earth. For countless generations, human eyes have looked toward it during clear winter nights, seeing only a faint mist among the stars. Modern telescopes reveal something far richer. Thousands of young stars quietly growing together inside glowing clouds. Far beyond Orion lies another remarkable nursery. The Carina Nebula stretches across an even greater region of space, filled with enormous pillars of gas and dust that seem almost sculpted by invisible hands. These towering structures resemble ancient cliffs rising through morning fog. Yet they are not made of stone. They are built from the same gentle ingredients that someday become stars, planets, and perhaps even living worlds. Elsewhere, enormous arcs of glowing gas quietly curve across the sky. One of the largest is known as Barnard's Loop. Rather than imagining a rigid boundary, picture a faint ribbon of mist drifting through a moonlit forest. Its graceful curve quietly marks ancient chapters in the long history of nearby star formation. Even after one generation of stars is born, the cloud continues changing, preparing future generations yet to come. Nothing here is wasted. The dust that gathers today may become planets tomorrow. The light born here may one day warm distant oceans. The heavier elements created inside these young stars will eventually be shared with the galaxy, becoming part of future mountains, future seas, and perhaps future eyes looking back toward the heavens. There is something quietly comforting about that thought. The universe does not simply create. It patiently recycles, again and again, cloud into star, star into light, light into possibility. And as these newborn stars slowly grow brighter, they begin the longest chapter of their lives, shining steadily across billions of years before age gently transforms them into something altogether different. The newborn stars behind you are still wrapped in soft clouds of dust, their light only beginning to spread into the surrounding darkness. They have taken millions of years simply to be born. Yet, compared with everything that lies ahead, they are still only children. A star lives an astonishingly long life, not because it rushes through time, but because it spends its days with remarkable patience. Imagine lighting a small candle inside a perfectly still room. If there is no wind, no sudden movement, and nothing to disturb the flame, it burns quietly for a very long time. A star is something like that gentle flame, although its light comes from processes far deeper than any candle could ever know. For billions of years, a star quietly shines. There is no hurry, no ambition, no destination to reach. It simply finds a beautiful balance between two quiet forces. Deep within its centre, gravity gently encourages everything to move inward. At the same time, tremendous warmth created in its heart gently presses outward. Neither side wins. Instead, they settle into a peaceful agreement. The star remains stable, round, bright, calm. Our own sun has lived this way for billions of years. Every sunrise you have ever seen has been part of this long chapter. Every warm afternoon, every tree that has quietly grown, every ocean wave that has sparkled beneath daylight. They all owe something to a star patiently maintaining its quiet balance. It is comforting to realize that, from the perspective of the sun, human history has unfolded in little more than a brief afternoon. Empires have risen and fallen, languages have changed, entire civilizations have appeared and disappeared. Yet the sun has continued its steady rhythm, offering light with extraordinary consistency. Stars, however, do not remain unchanged forever. Even the most patient flame slowly uses the fuel that allows it to shine. The change comes so gradually that no one generation could ever watch it happen. If you could somehow observe a star for millions upon millions of years in only a few quiet moments, you would notice a slow transformation beginning. Its center changes first. The balance that has lasted for so long begins to shift. The outer layers of the star gently respond. Almost without warning, although only on cosmic timescales, the star begins to grow. Imagine an old oak tree slowly stretching wider each year, its branches reaching farther, its shade covering more ground. The tree is still the same tree. It has simply entered a different season of life. Stars experience something similar. They become what astronomers call red giants. The name sounds enormous because it truly is. A star that once seemed comfortably ordinary gradually swells until it becomes many times larger than before. If our own sun eventually reaches this peaceful stage, its outer layers will slowly expand far beyond their present size. The inner planets will no longer experience the familiar warmth they know today. The solar system itself will become a quieter, gentler place, reshaped by the slow aging of its central star. Despite its great size, a red giant is not becoming stronger. In many ways, it is becoming softer. Its outer layers spread farther apart. Its glow changes to warmer shades of orange and deep red. Imagine watching autumn arrive in a quiet forest. The brilliant greens slowly give way to gold, amber, and crimson. Nothing feels tragic, only beautifully different. Deep inside the star, another quiet chapter begins. The center becomes warm enough for a new kind of gentle transformation to unfold. Astronomers describe this moment as helium ignition. The words may sound sudden, but the reality is far less dramatic than they suggest. Imagine placing another small log onto a calm fireplace. The fire does not leap wildly toward the ceiling. Instead, it simply discovers another source of gentle warmth, allowing it to continue burning peacefully for a while longer. The star has found another way to keep shining. As time continues its patient work, some aging stars become especially rich in carbon. Their outer layers fill with tiny particles that gently colour their light. Instead of shining with familiar golden tones, these remarkable stars glow with deep copper, soft crimson, and warm ruby shades. They're often called carbon stars. Looking at one through a telescope is rather like watching a glowing ember resting quietly beneath the ashes of a long evening fire. Warm, steady, unhurried. Eventually, Even this peaceful chapter reaches its natural conclusion. The star begins releasing its outer layers into space. These delicate shells of glowing gas slowly drift away, expanding with extraordinary grace. From Earth, they often resemble luminous flowers blooming in the darkness, or delicate soap bubbles catching the last colours of sunset. Astronomers know these beautiful clouds as planetary nebulae. The name can be a little misleading. They have very little to do with planets. Long ago, through early telescopes, their gentle round shape simply reminded observers of distant worlds. The name remained, even as our understanding quietly grew. As the glowing cloud slowly expands into the galaxy, only the small central core of the star remains. This quiet remnant is called a white dwarf. Although only about the size of Earth, it contains an astonishing amount of matter gathered into an incredibly compact sphere. There are no roaring flames surrounding it now, no great expansion, only the lingering warmth of a life already lived. Imagine removing a loaf of bread from the oven. Long after the baking is finished, the loaf continues giving off gentle warmth. No new heat is being created, it simply holds on to what already exists. A white dwarf behaves in much the same peaceful way. For billions upon billions of years it slowly cools. Its light becomes softer. Its warmth gradually fades. Eventually, so far in the future that the universe itself is still far too young for any to exist, a white dwarf would become what astronomers imagine as a black dwarf. Not a black hole, not an object swallowing light. Simply a star that has quietly cooled until almost all of its remaining warmth has drifted away into the vastness of space. None have yet had enough time to reach that final stage. The cosmos itself has not been around long enough. Even here, patience is still unfolding, yet perhaps the most beautiful part of a star's story is not its ending. It is what the ending leaves behind. The gentle clouds released during its final years carry newly formed elements out into the galaxy. Those atoms slowly become part of future clouds, future stars, future planets, perhaps future oceans, perhaps even future living beings looking upward with quiet curiosity. A star never truly keeps its gifts. It shares them, again and again, generation after generation. The universe quietly recycles nearly everything, and while many stars fade with this peaceful grace, others are born so immense that they refuse such gentle endings, choosing instead lives of unimaginable size and extraordinary power. As you leave behind the gentle old stars that slowly released their final clouds into the galaxy, another family of stars begins to emerge from the darkness. At first they seem familiar. They glow with warm colours. They illuminate nearby clouds. They patiently fill space with light, just as countless other stars have done for billions of years. But the closer you drift, the more you realise these are not ordinary stars. They belong to an entirely different scale. Imagine standing beneath a single ancient tree. Its branches stretch so far that you cannot easily see where they end. Its trunk seems wider than a house. Its shadow quietly covers an entire meadow. You do not feel frightened. You simply become aware of your own smallness. The larger stars create a similar feeling. They do not seem enormous because they are loud. They seem enormous because they quietly occupy so much of the universe around them. Some are known as red supergiants. Like the red giants you visited before, they have entered the later chapters of their lives. But these stars began their stories with far greater mass. Everything about them is amplified. Their light, their size, even their slow breathing as their outer layers gently expand and contract over time. If one of these immense stars could take the place of our own sun, its outer atmosphere would stretch astonishingly far into the solar system. The familiar paths of the inner planets would disappear inside its vast glowing envelope. Mercury would be lost, Venus would be lost, even Earth would no longer travel beneath open space. it would rest deep within the gentle outer layers of its aging star. The comparison is almost impossible to picture, not because these stars are crowded or dense. In fact, much of their enormous size comes from their outer layers becoming surprisingly thin and spread out. Imagine taking a single handful of soft cotton and slowly pulling it apart. The cloud becomes larger and larger, even though the amount of material remains the same. These giant stars grow in a similarly graceful way. Their immense size is not a sign of heaviness alone. It is also a sign of gentle expansion. Among these remarkable stars, one has become especially well known for its astonishing scale. Astronomers call it Stephenson 218. The name may sound unusual, but there is no need to remember it. Instead, simply imagine one of the largest stars humanity has ever identified. A glowing sphere so immense that ordinary comparisons begin to lose their meaning. It reminds us that the universe still contains objects larger than our imagination comfortably expects. Yet even this extraordinary giant is not alone. Elsewhere shines another remarkable star called Eta Carinae. For many years, astronomers watched it carefully because it behaved in an unusually restless way. Long ago, it experienced an enormous outburst, releasing tremendous clouds of gas into the surrounding space. From Earth, those expanding clouds now resemble a delicate glowing hourglass suspended in the darkness. Although the event itself involved extraordinary energy, the cloud has spent generations quietly unfolding, expanding with remarkable patience. Even powerful moments become peaceful when viewed across the timescales of the universe. As these immense stars continue aging, some gradually shed their outer layers almost like trees releasing leaves during autumn. Powerful stellar winds carry material away into space. Eventually only an intensely hot inner star remains, shining through the disappearing cloud. Astronomers know these unusual stars as Wolf-Rayet stars. They are among the brightest and hottest stars known, wrapped in powerful streams of gas flowing steadily into the surrounding galaxy. Imagine standing on a quiet hill as a steady breeze carries flower petals into the air. The petals drift farther and farther away until they become part of the landscape itself. These stellar winds perform a similar task, except the journey lasts hundreds of thousands of years rather than a single afternoon. The material released today may someday help create entirely new generations of stars. Eventually, however, even the greatest giants reach a moment when gentle change is no longer enough. Deep inside, the star has exhausted nearly every way it knows to continue shining. For millions of years, gravity and warmth lived in peaceful balance. Now gravity slowly gains the upper hand. The enormous core can no longer support the weight above it. The collapse happens incredibly quickly by cosmic standards. Almost immediately afterward, the outer layers race outward into space. Astronomers call this remarkable farewell a supernova. From across the galaxy, it may briefly shine with the brilliance of billions of ordinary stars combined. Yet even this magnificent event is only a brief heartbeat in the lifetime of the universe. Long after the brilliant light has faded, something extraordinary remains. If the original star was sufficiently massive, its central core becomes an object almost beyond imagination. Picture an entire mountain somehow compressed until it could fit inside a grain of sand. The comparison is not exact, yet it hints at something important. Matter itself has become astonishingly compact. The result is called a neutron star. Although only about the size of a large city, it contains more matter than our own sun. Its gravity is extraordinary. Its surface is unlike anything found anywhere on Earth. Some neutron stars spin with astonishing regularity. As they rotate, narrow beams of light sweep through space like the gentle turning of an old lighthouse beside a quiet sea. If one of those beams happens to pass across Earth, astronomers observe a steady rhythm of tiny flashes. These remarkable objects are called pulsars. Their signals are so dependable that they resemble the patient ticking of an ancient cosmic clock. Among them exists an even rarer family. These are magnetars. They possess magnetic fields so extraordinarily powerful that they challenge ordinary intuition. Fortunately, there is no need to imagine their mathematics or their measurements. Instead, simply think of them as the universe exploring one of the strongest expressions of magnetism nature appears capable of creating. Even here, amid such astonishing extremes, the universe remains surprisingly quiet. The neutron star does not roar. The pulsar does not rush. The magnetar does not seek attention. They simply exist, patiently carrying the memory of a giant star that once illuminated an entire region of the galaxy. There is something deeply comforting in that continuity. Nothing truly disappears. Clouds become stars. Stars become giants. Giants become brilliant remnants. And those remnants quietly prepare the materials that future generations of stars will inherit. Yet among all these remarkable endings, one possibility remains even stranger. Sometimes gravity refuses to stop. Sometimes the collapsing heart of a giant star continues falling inward beyond anything we can easily imagine, leaving behind one of the greatest mysteries in the universe. The giant stars have now lived their extraordinary lives. Some have quietly faded into dense little remnants that continue spinning beneath the stars. Others have scattered their final gifts across the galaxy, leaving behind clouds that will someday become new worlds. But every so often, one of those enormous stars reaches an ending unlike any other. Not louder, not more important, simply stranger. Imagine holding a soft blanket by its four corners. At first it hangs gently beneath its own weight. Now imagine placing a smooth stone at its centre. The blanket bends slightly. Place a larger stone upon it, and the curve becomes deeper. The heavier the stone becomes, the more the blanket quietly folds inward. Gravity behaves in a surprisingly similar way. Every object gently shapes the space around it. Most stars create broad, graceful curves. Planets create smaller ones. Even you create an unimaginably tiny curve, although far too small for anyone to notice. Now imagine a star so massive that, after its long life has come to an end, nothing remains to support its own tremendous weight. Its gentle balance is finally gone. Gravity no longer shares the work. It quietly takes over. The star begins to collapse inward, not because something is pulling it from outside, because its own weight patiently guides every part toward the center. Smaller, smaller still, until something remarkable appears. A black hole is born. The name may sound dark, perhaps even unsettling. Yet a black hole is not a hole in the ordinary sense. There is no tunnel through space, no great opening waiting to swallow everything nearby. Instead, you might imagine it as a place where gravity has become extraordinarily deep, rather like an immense valley whose slopes descend beyond anything familiar. If you were gently floating far away, nothing would seem unusual. Stars would still shine. The surrounding galaxy would remain beautiful. Only when you drifted closer would you begin to notice that the paths of nearby objects slowly curve toward an unseen center. There is another idea often associated with black holes. Astronomers call it the event horizon. The words may sound technical, but the idea itself can be imagined quite gently. Picture yourself rowing across a calm river. Far ahead lies a quiet waterfall. While you remain far enough away, you can still turn your boat around and paddle back upstream. The current grows stronger as you approach, but escape remains possible. Eventually, however, there comes a point where the river quietly carries everything forward. No matter how hard you row, the current has become too strong. That invisible place of no return is something like the event horizon. It is not a wall. It is not a surface. Nothing dramatic marks its location. It is simply the quiet boundary beyond which every possible path leads farther inward. Around many black holes, matter does not fall directly into the centre. Instead, it begins a long, graceful spiral. Imagine leaves floating toward the middle of a slow whirlpool. They circle, then circle again. Each gentle orbit brings them slightly closer to the centre. Gas and dust behave in much the same way. As they spiral inward, they rub softly against neighbouring particles. That gentle friction produces tremendous warmth. The material begins glowing brilliantly. Astronomers call these luminous structures accretion disks. You might simply imagine them as glowing rivers of light slowly circling an invisible destination. Ironically, the brightest part of a black hole is often not the black hole itself. It is everything quietly dancing around it. Not all black holes are alike. Some begin as the quiet remains of individual giant stars. These are known as stellar black holes. Others grow into something almost beyond imagination. At the hearts of most galaxies, including our own, rests a supermassive black hole. Rather than comparing its size, perhaps it is better simply to picture it as the silent anchor around which an entire galaxy slowly turns. Hidden deep within the centre of the Milky Way lies one such giant. Astronomers call it Sagittarius A. Although it cannot be seen directly, generations of careful observations have revealed stars patiently circling an invisible point, faithfully tracing the presence of something enormously massive. Between these two families may exist another quieter group. Intermediate black holes appear to bridge the gap between stellar remnants and galactic giants. Astronomers continue searching for them, slowly adding new pieces to a puzzle that remains unfinished. There is also an even more speculative possibility. Some scientists have wondered whether tiny black holes could have formed during the universe's earliest moments, long before the first stars ever shone. These hypothetical objects are known as primordial black holes. No one has confirmed their existence. For now, they remain gentle possibilities resting at the edge of scientific imagination, reminding us that curiosity often travels farther than certainty. For many years, black holes remained invisible in another sense as well. No one had ever seen one directly. Then, after extraordinary international cooperation, many radio telescopes across Earth worked together as though they were one enormous instrument, patiently collecting signals, comparing observations, and assembling tiny pieces of information. They produced humanity's first image of the glowing material surrounding a black hole. The photograph appeared surprisingly soft. A warm ring of golden light surrounding a quiet shadow. Not a monster. Not a whirlpool racing through space. Simply a silent silhouette against a gentle halo of light. It became one of astronomy's most peaceful portraits. For a long time, many people imagined black holes as eternal. Once formed, they would simply remain forever. Yet one of the most beautiful ideas in modern physics gently suggests something different. The physicist Stephen Hawking proposed that black holes may slowly lose incredibly tiny amounts of energy over unimaginably long periods of time. The process is now known as Hawking radiation. You need not picture complicated mathematics. Instead, imagine a block of ice resting in a cool room. Even though it appears solid and unchanging, tiny amounts slowly disappear into the air. The change is almost impossible to notice from one moment to the next. Yet given enough time, the ice quietly becomes smaller. If Hawking's idea is correct, black holes may behave in their own astonishingly patient way. Not today, not tomorrow, not even while the stars still shine across the universe, but over spans of time so immense that ordinary language struggles to describe them. Even these great cosmic valleys may slowly soften, little by little, almost imperceptibly. Until one day, after ages beyond imagination, they too may gently fade into the quiet darkness. There is something unexpectedly comforting about that thought. Even the universe's deepest mysteries are not frozen forever. Everything changes, everything evolves, everything participates in the same patient story. And while black holes quietly anchor the hearts of galaxies, those galaxies themselves are drifting through a far greater ocean of stars, waiting for us to begin the next gentle stage of our journey. For much of our journey, the Milky Way has been little more than a distant backdrop, a soft ribbon of light stretching quietly across the night, a gentle reminder that our sun belongs to something much larger. Now, instead of looking toward our galaxy, you slowly drift inside it. Imagine floating high above a calm ocean, just before sunrise. From the shoreline, the sea appears endless, but from above, gentle patterns begin to reveal themselves, long currents, graceful curves, quiet movements that could never be seen from the surface alone. The Milky Way is much the same. From Earth, we see only a glowing band crossing the sky. From afar, a far richer picture begins to emerge. Our galaxy is shaped like a great spiral. Its stars gather into broad, gently curving arms that wind around a bright central heart. These are not solid arms like the spokes of a wheel. They are more like slow-moving rivers. Imagine watching fallen leaves drifting along a peaceful stream. The stream itself keeps its graceful shape, even though the individual leaves quietly come and go. The spiral arms behave in a similar way. Stars are born within them. Others slowly drift beyond them. New clouds arrive. Old stars continue their long journeys. Yet the beautiful spiral pattern patiently remains. Our own sun lives within one of the quieter neighbourhoods of this great galaxy. Not too close to the crowded centre. Not too close to the lonely outer edge. Instead, it quietly circles within a smaller spiral branch, completing one enormous journey around the galaxy in hundreds of millions of years. Every time the sun completes one full orbit, countless generations of life may have appeared and disappeared upon Earth. The galaxy measures time differently. Its days are written in ages rather than hours. As you continue your slow flight inward, the number of stars gradually increases. The sky becomes richer, brighter. The darkness between the stars grows softer. Eventually, a broad shadow begins to stretch across part of your view. At first, it seems strange. Why would there be darkness inside such a brilliant galaxy? The answer is surprisingly gentle. Between many of the stars lie vast clouds of dust. These clouds quietly absorb and scatter light, creating long dark lanes that appear to divide the glowing river of the Milky Way. From Earth, one of the most beautiful of these dark regions is known as the Great Rift. Imagine standing on a quiet hillside as morning fog drifts through a forest. The trees remain where they have always been, only the mist gently hides them from view. The Great Rift performs a similar role on a galactic scale. It does not remove the stars, it simply wraps them in soft veils of dust until their light becomes faint. Passing through these dusty regions feels strangely peaceful. The stars become fewer. The light grows gentler. Every now and then, a newborn star quietly shines through the cloud like a lantern glowing behind a curtain. Eventually, the dust begins to thin once more. Ahead, the heart of the Milky Way slowly brightens. The galactic centre is unlike the peaceful neighbourhood surrounding our sun. Here, countless stars gather much more closely together. The sky would never become truly dark. Light would spill across the heavens from every direction. Clouds of glowing gas drift between dense clusters of ancient stars. Deep within this crowded region rests the quiet, supermassive black hole we visited earlier, patiently anchoring the motions of the surrounding stars. Yet even here, the galaxy feels less like a crowded city and more like an ancient forest. Every star follows its own path, each quietly respecting the invisible pull of gravity shared by all. As you drift away from the brilliant centre, another layer of the galaxy quietly reveals itself, Most familiar stars, including our Sun, travel within a broad, gently flattened region known as the thin disk. Imagine a calm lake whose surface stretches peacefully toward every horizon. Most of the galaxy's bright young stars live within this quiet layer. Above and below it lies a thicker, older population of stars. Astronomers call this the thick disk. These ancient travellers move on slightly different paths, carrying memories from much earlier chapters in the Milky Way's history. Farther still, the galaxy begins to dissolve into something even quieter. The stellar halo surrounds the Milky Way like a delicate cloud. Its stars are few, widely separated. Some are among the oldest in our galaxy, quietly continuing journeys that began billions of years ago. Imagine tiny fireflies scattered across a vast meadow on a warm summer night. Each glows softly, each remains wonderfully alone. Yet together they create a quiet beauty impossible for a single light to achieve. One of the greatest gifts modern astronomy has received came from a remarkable spacecraft called Gaia. For years, it patiently measured the positions and motions of more than 1 billion stars, not to produce dramatic discoveries overnight, but to create the most detailed map of our galactic home ever assembled. Imagine watching every bird in a great forest for many seasons, slowly learning how each one flies. Eventually, hidden patterns begin to emerge, old migrations become visible, forgotten streams reveal themselves. Gaia has allowed astronomers to notice similar patterns among the stars. One of these is the Sagittarius stream. Long ago, a much smaller galaxy wandered too close to the Milky Way. Over immense stretches of time, gravity gently drew its stars into long flowing ribbons that now wrap around our own galaxy. The original visitor has largely disappeared, yet its stars continue their graceful journey, quietly preserving the memory of an ancient encounter. Perhaps the most mysterious part of the Milky Way cannot be seen at all. Everything we have admired, the stars, the glowing clouds, the dark lanes of dust, appears to be surrounded by something invisible. Astronomers call it dark matter. You do not need to imagine hidden particles or complicated theories. Instead, picture a gentle breeze moving through a meadow. You cannot see the wind itself, yet every blade of grass quietly leans in response. In much the same way, the stars of our galaxy move as though they are being held by an unseen presence extending far beyond the visible spiral. Without it, the galaxy as we know it might not remain together. Invisible though it may be, its quiet influence reaches everywhere. As you look back one final time, the Milky Way no longer feels like an impossibly large collection of distant stars. It feels like home, a patient island of light drifting through an even greater darkness. And soon, as you continue your gentle journey outward once more, you will discover that our home is only one island among hundreds of billions of others, each quietly carrying its own oceans of stars across the endless universe. As the Milky Way slowly becomes smaller behind you, something remarkable begins to happen. For much of our journey, home has felt unimaginably large. Its hundreds of billions of stars seemed endless. Its graceful spiral arms stretched farther than the imagination could comfortably travel. Yet as you continue drifting outward, the galaxy itself gradually becomes only one gentle island of light. Around it, more islands begin to appear, then dozens, then hundreds, then so many that counting no longer feels meaningful. The universe is not filled with only one great city of stars. It is an immense archipelago, where every galaxy quietly carries its own history, its own rhythm, and its own quiet beauty. From a great distance, many galaxies resemble delicate seashells, soft spirals winding inward toward glowing centres. These spiral galaxies are among the most familiar. Their graceful arms are filled with young stars, glowing clouds, and the quiet nurseries where future suns continue to awaken. If galaxies could dream, spiral galaxies might dream in slow circles. Their arms do not spin like the blades of a fan. Instead, Imagine watching gentle ripples moving across a wheat field beneath a calm breeze. The pattern drifts onward, while each individual stalk quietly remains part of the field. The spiral arms behave in much the same patient way. Stars are continually moving. The graceful pattern quietly endures. Not every galaxy chooses such elegant curves. Some appear as enormous glowing ovals, smooth and featureless. These are known as elliptical galaxies. From afar, they resemble ancient lanterns wrapped in soft golden mist. Their brightest days often lie far behind them. Most of their stars were born long ago. Now they shine peacefully together, with relatively few new stars appearing. There is something deeply restful about these galaxies. They seem content simply to glow, quietly, steadily, as though they have settled into a long and comfortable evening after an active youth. Others surprise us entirely. Imagine dropping a single pebble into the still surface of a pond. A perfect ripple quietly expands outward. Some galaxies display a surprisingly similar appearance. A brilliant ring of stars surrounds a quieter centre, giving the impression of an enormous cosmic ripple suspended in the darkness. These are called ring galaxies, many likely formed after another galaxy passed gently through their centre long ago. The encounter was not a violent crash in the everyday sense. Remember that galaxies are mostly empty space. Stars are separated by astonishing distances. When galaxies meet, individual stars almost always pass peacefully by one another. Instead, gravity quietly rearranges the larger patterns, sending waves through clouds of gas and gently encouraging new stars to form. The result is less like two solid objects colliding, and more like two schools of fish slowly swimming through one another beneath a quiet sea. Some galaxies appear even more unusual. Long streams of glowing gas trail behind them, stretching across the darkness like delicate ribbons. These are often called jellyfish galaxies. The name is wonderfully fitting. Imagine watching a jellyfish drifting through calm water, its graceful tentacles following silently behind. As certain galaxies travel through enormous clusters filled with extremely thin hot gas, some of their own gas is gently pulled away, leaving behind beautiful trailing streams. Even this quiet loss becomes an opportunity. New stars may continue forming within those drifting ribbons, carrying light far beyond their original homes. Among the countless galaxies scattered across the universe, a few have become especially beloved. One wears a broad, glowing band of dust wrapped neatly around its bright centre, giving it the appearance of a wide-brimmed hat. Astronomers know it as the Sombrero Galaxy. Another possesses a dark band across one side of its glowing core, creating the impression of a gentle shadow surrounding a single eye. It has become known as the Black Eye Galaxy. These names remind us that science is not entirely separate from imagination. Even careful observers sometimes borrow familiar images from everyday life when describing extraordinary places. Far beyond these nearby examples lies another remarkable galaxy that astonished astronomers because of the extraordinary speed with which it created new stars. It became known as the Baby Boom Galaxy, a playful name for a place where countless young stars appeared in an exceptionally active period of cosmic history. Most galaxies form stars at a patient pace. This one seemed determined to celebrate a season of remarkable abundance. Such galaxies belong to a broader family known as starburst galaxies. Imagine a quiet forest that, after many peaceful years, suddenly becomes filled with countless new seedlings following a season of perfect rain. The forest is still the same forest. It has simply entered an especially productive chapter. Starburst galaxies experience something similar. Their clouds of gas become extraordinarily active, allowing new generations of stars to appear much more rapidly than usual. Occasionally, at the centres of distant galaxies, something even brighter quietly awakens. Material slowly spirals toward an enormous central black hole. As it circles inward, it grows intensely hot, producing extraordinary amounts of light. From unimaginably far away, these brilliant centres may outshine every star within their own galaxy combined. Astronomers call them quasars. Although they appear almost like individual stars through smaller telescopes, they are actually the glowing hearts of distant galaxies viewed across enormous stretches of space and time. Their light has often travelled for billions of years before reaching us. They are less like fireworks and more like ancient lighthouses whose beams have crossed the deepest oceans of the universe. Perhaps the most beautiful lesson galaxies teach us is that change rarely arrives through sudden endings. Over billions of years, galaxies slowly approach one another. Gravity gently reshapes their paths. Clouds drift together. New stars quietly emerge. The galaxies themselves gradually transform into something neither one could have become alone. Our own Milky Way is expected to experience such a meeting one day with the neighbouring Andromeda galaxy. Not tomorrow, not for countless generations. The night sky has plenty of time. When that distant future finally arrives, the stars themselves will almost certainly continue passing peacefully by one another. Instead, the galaxies will slowly weave together like two gentle rivers meeting across a broad plain. There will be no rush, only another quiet chapter in the universe's patient story. As you continue drifting farther outward, even galaxies themselves begin gathering into larger families, quietly revealing that these glowing islands are connected by structures far greater than anyone once imagined. As the last nearby galaxies slowly drift behind you, something unexpected begins to appear. For a long time, each galaxy seemed complete, a graceful island of stars quietly carrying its own clouds, its own black hole, its own patient history through the darkness. It would be easy to imagine that galaxies simply wander alone, each following its own endless path across an empty universe. But the farther you travel, the more gently that idea begins to change. Imagine standing on a quiet shoreline at dawn. At first, you notice only a single island resting upon the calm sea. As the morning mist slowly lifts, another island appears, then another. Soon you realize they're not isolated at all. They belong to an entire chain stretching far beyond the horizon. The universe offers a similar surprise. Galaxies often gather into small families. Just as neighborhoods quietly form within cities, these families become the first gentle layer of something much larger. Our own Milky Way belongs to one such gathering. Several nearby galaxies, each carrying billions of stars, slowly dance together under their shared gravity. None rush, none collide in haste. They simply follow quiet paths that have unfolded over billions of years. As you continue drifting outward, these small families begin joining even larger communities. Hundreds, sometimes thousands, of galaxies quietly orbit one another within enormous collections known as galaxy clusters. Imagine standing beneath a clear winter sky and watching a flock of birds slowly circle together in perfect harmony. Each bird follows its own path, yet together they create graceful patterns, impossible for any one bird alone. Galaxy clusters behave in much the same way. Every galaxy keeps its own identity, yet gravity gently guides them into vast, slow-moving communities. The spaces between the galaxies remain almost unimaginably empty, and yet they are not entirely empty. A thin sea of incredibly hot gas quietly fills much of the space between them. Invisible to human eyes, it gently glows in forms of light that specialized telescopes can detect. Even the emptiness, it seems, carries its own quiet presence. The journey continues. Clusters themselves begin gathering into still larger regions. Astronomers once called these enormous collections superclusters. Today, they understand that the picture is even more beautiful than that simple word suggests. Our own galactic neighbourhood belongs to a vast region called Laniakea. The name comes from the Hawaiian language and is often translated as immeasurable heaven. It is a remarkably gentle name for something so immense. Rather than imagining rigid borders, picture countless rivers slowly flowing across a peaceful landscape. Tiny streams become larger rivers. Those rivers eventually share the same broad valley. Laniakea is something like that. Not a solid object, not a wall, simply a vast region where countless galaxies quietly follow similar currents through space. Yet even Laniakea is not the largest pattern waiting to be discovered. As you drift farther away still, the universe begins revealing one of its most breathtaking secrets. The galaxies do not appear scattered randomly. Instead, they seem connected by enormous filaments stretching across the darkness. Imagine walking through a meadow early in the morning, where delicate spider webs are covered with tiny drops of dew. From a distance, each web seems separate. Step back a little farther, and the fine threads begin connecting into something much larger than you first imagined. The universe appears to have woven itself in much the same way. Astronomers call this magnificent structure the cosmic web. The name is wonderfully descriptive. Enormous strands of galaxies quietly stretch across space like delicate threads woven through an endless piece of dark fabric. Between those threads lie immense regions where comparatively few galaxies exist. Not because the universe forgot those places, simply because gravity has spent billions of years gently gathering matter into the great filaments instead. It is impossible to see the entire cosmic web with your own eyes. It is simply too vast. Instead, astronomers patiently assemble countless observations, each one adding another small thread until the larger tapestry slowly becomes visible, like someone weaving an enormous blanket one careful stitch at a time. There is another quiet mystery hidden among these great structures. As galaxies move through space, many seem to drift toward a distant region that cannot be fully explained by the visible matter alone. Astronomers refer to this broad destination as the Great Attractor. The name may sound dramatic, but there is no giant object waiting there like a cosmic vacuum. Instead, imagine standing beside a wide river. You cannot immediately see where the water is ultimately flowing, yet every leaf upon the surface slowly follows the same gentle direction. The Great Attractor is rather like that unseen destination. It reminds us that gravity continues shaping the universe even where our understanding remains incomplete. Far beyond these regions, astronomers have discovered structures so enormous that ordinary comparisons begin to lose their usefulness. One is known as the Sloan Great Wall. Another bears the longer name Hercules Corona Borealis Great Wall. There is no need to remember either name. Instead, simply imagine astonishingly long regions where galaxies gather in extraordinary abundance, forming immense patterns that stretch farther than early astronomers once believed possible. They are not walls like those built by human hands. They are gentle concentrations, broad regions where countless galaxies quietly share the same immense architecture. Even these enormous structures are not separate from the cosmic web. They are among its brightest threads, individual stitches within an unimaginably vast tapestry. As you continue drifting ever farther away, the galaxies become smaller once more. The glowing filaments themselves begin to resemble the delicate veins of a leaf, or the branching roots of an ancient tree spreading quietly beneath the soil. Everywhere you look, the same gentle pattern repeats. Small things gather into larger ones. Stars become galaxies. Galaxies become clusters. Clusters become rivers of light stretching across the universe. And through it all, invisible gravity patiently weaves the threads together. There is something deeply comforting about that quiet order. The universe is not a random scattering of isolated lights. It is a connected tapestry, A vast work of patient craftsmanship still unfolding after billions of years. Yet perhaps the most astonishing realization is this: everything you have admired so far, every star, every planet, every galaxy, every glowing thread, appears to represent only a small part of what truly exists. Most of the universe remains hidden, quietly shaping the story from beyond the reach of ordinary light. You have now drifted farther than almost anyone naturally imagines. Behind you lie quiet planets wrapped in endless oceans, stars patiently growing old, black holes resting at the hearts of galaxies, entire rivers of galaxies woven together into the delicate threads of the cosmic web. It feels as though the universe has gradually revealed itself, and yet, one of astronomy's most remarkable discoveries is that almost everything you've seen so far may represent only a small part of the whole. Imagine walking through a forest just after sunrise. Golden light filters softly through the trees. You hear birds singing somewhere above. Leaves gently move in a cool breeze. Everything feels complete. Yet beneath your feet lies an enormous hidden world. Roots spread quietly through the soil. Tiny rivers of water travel between stones. Countless living organisms continue their patient work beyond your sight. The forest has always been larger than what your eyes could easily observe. The universe appears to be much the same. For centuries, astronomers believed that if they carefully collected enough light, they would eventually understand nearly everything that existed. Brighter telescopes were built. Sharper images appeared. Farther galaxies were discovered. Each generation gently extended humanity's view. But as the picture became clearer, something unexpected happened. The numbers no longer seemed to agree. Galaxies were spinning in curious ways. Clusters of galaxies remained held together more strongly than visible matter alone seemed able to explain. It was rather like watching leaves drifting across a quiet meadow. You cannot see the wind itself, yet every leaf gently bends in the same direction. The unseen breeze quietly reveals its presence through everything it touches. Astronomers found themselves noticing similar invisible footprints across the universe. Something appeared to be guiding the motions of stars and galaxies. Something that did not shine. Something that did not glow. Something that seemed almost entirely invisible. They gave this quiet mystery a simple name: dark matter. The name does not mean that it is dark like a shadow, nor does it suggest something frightening. It simply reminds us that whatever it is, it does not reveal itself by producing ordinary light. Imagine holding a clear sheet of glass. You hardly notice the glass itself. Instead, you notice how the world behind it appears ever so slightly changed. Dark matter behaves in a similarly quiet way. Astronomers rarely observe it directly. Instead, they notice how gravity gently changes the paths of stars, galaxies, and even light itself. Its presence is revealed by the graceful influence it leaves behind, not by its appearance. There is something wonderfully humble about this idea. One of the greatest discoveries in modern astronomy is something we cannot simply point a telescope toward and see. Instead, we notice its quiet footprints, its gentle fingerprints upon the universe. Yet the hidden story becomes even stranger. Late in the 20th century, astronomers carefully measured the expansion of the universe. Most people expected that gravity would slowly reduce that expansion over time. Imagine tossing a ball gently upward into the sky. It climbs, gradually slows, then eventually begins returning toward the ground. The universe seemed likely to behave in a similar fashion. Instead, careful observation suggested something entirely unexpected. The expansion itself appears to be gently speeding up. It is as though the great cosmic fabric is continuing to stretch, and somehow finding itself stretching a little more easily with time. No one expected such an answer. To describe this quiet mystery, astronomers introduced another simple name: dark energy. Once again, the name does not explain the mystery. It merely gives us a way to talk about something whose true nature remains unknown. Perhaps that honesty is one of science's greatest strengths. When scientists do not know the answer, the most careful response is often simply, "We do not know yet." There is another puzzle that quietly reminds us how much remains unfinished. As astronomers carefully count the ordinary matter expected throughout the universe, not every piece seems immediately accounted for. Some of it hides in faint clouds of gas stretched between galaxies. Some is extraordinarily difficult to observe directly. Over time, better telescopes have gradually uncovered more of these missing pieces. The story continues changing with every generation of observation. Even absence can become a path toward discovery. Long before galaxies existed, long before stars quietly lit the darkness, the universe itself may have experienced an astonishingly rapid beginning. Astronomers often describe this idea using the phrase cosmic inflation. The words may sound technical, but the image can remain wonderfully gentle. Imagine blowing softly into a tiny soap bubble. For one brief moment, the bubble expands with surprising speed, before settling into a slower, steadier growth. The early universe may have experienced something loosely similar, a very brief period of extraordinary expansion, followed by the long, patient evolution we have been quietly exploring throughout this journey. No one has ever watched this happen directly. Instead, scientists gently gather clues, much as an archaeologist carefully pieces together an ancient story from scattered fragments. Each observation becomes another small tile in an unfinished mosaic. Perhaps the most comforting realization is not that astronomy has answered every question, it is that it has not. The universe still keeps many of its quietest secrets. Every powerful telescope uncovers new mysteries alongside new discoveries. Every answer gently opens another door. Science does not move because certainty has already arrived. It moves because curiosity continues walking forward. There is no embarrassment in saying, "We're still learning." In fact, there is something deeply beautiful about it. The universe is not a puzzle waiting impatiently to be completed. It is an endless conversation, patient, generous, always inviting another careful question as you float within this immense darkness, surrounded by invisible influences you cannot directly see. You begin to understand that seeing has never been the only way of knowing. Sometimes you notice the wind by watching the grass. Sometimes you understand the river by listening to its quiet current. Sometimes you recognize an unseen traveler by the gentle footprints left behind. The hidden universe speaks in much the same way, softly, indirectly, patiently. And perhaps the greatest mystery of all still waits beyond the farthest light we can ever hope to observe, where even the horizon of the visible universe quietly gives way to possibilities no telescope can yet reach. For every step of this journey, light has been your faithful companion. It carried the glow of distant stars across unimaginable distances. It revealed quiet galaxies resting at the edges of space. It whispered stories that began billions of years before your own world was born. Everything you have seen has arrived because light patiently travelled long enough to reach you. But now a gentle question begins to appear. What happens beyond the farthest light? Imagine standing on a quiet beach at sunrise. The ocean stretches endlessly before you. Far away, the horizon forms a delicate line where sea and sky seem to meet. No matter how carefully you look, you cannot see beyond it. Not because nothing exists there, simply because your view has reached its natural limit. The universe has a horizon of its own. Astronomers often call it the observable universe. The name is wonderfully honest. It does not describe everything that exists. It describes everything whose light has had enough time to arrive. There may be far more beyond, perhaps vastly more. But if light from those distant places has not yet completed its journey, they remain hidden from us today. It is important to remember that this horizon is not a wall. There is no great edge where space suddenly ends. Imagine walking through a dense morning fog. The world continues beyond the mist, even if your eyes cannot follow it. As the fog slowly lifts, you see farther. The landscape has not grown. Your view has simply expanded. Our understanding of the universe works in much the same gentle way. Each new generation of observations allows us to see a little farther into the great distance. Not because the universe is becoming larger, but because more of its ancient light has quietly reached us. There is another beautiful idea that often surprises people. The universe is expanding. It is tempting to imagine galaxies flying outward through empty space like birds leaving a tree. But the picture is softer than that. Imagine drawing several tiny dots on the surface of an uninflated balloon. As the balloon slowly fills with air, every dot gently moves farther from the others. The dots themselves do not crawl across the surface. The surface itself quietly stretches between them. Space behaves in a somewhat similar way. The galaxies are not simply racing through a fixed emptiness. The great fabric of space itself slowly expands, gently increasing the distance between faraway regions of the cosmos. Because of this continuing expansion, there are places so distant that their light may never reach us. Not because the light has stopped travelling. Light never grows tired. It continues patiently onward. But while it travels, the space between us continues stretching. The destination quietly recedes. It is rather like walking across a moving walkway that carries the far end gently away from you. You continue walking. The path continues lengthening. Some journeys may simply take longer than the lifetime of the universe itself. Beyond this gentle horizon lies one of the quietest questions in science. What exists where we cannot see? The most careful answer remains beautifully simple. We do not know. Yet human curiosity has never been content to stop wondering. Some scientists have imagined that our observable universe could be only one vast region within something even greater. Imagine walking through a peaceful meadow after rainfall. Tiny soap bubbles rest upon the grass. Each reflects its own little world of light. Each appears complete from within. Yet together they are only part of a much larger landscape. Some cosmological ideas imagine universes in a somewhat similar way. Great cosmic bubbles, each quietly existing alongside others beyond our view. No telescope has yet confirmed such a picture. For now, it remains a thoughtful possibility rather than an established fact. Other ideas ask a different question. What if the fundamental rules of nature could have been slightly different? Imagine baking the same loaf of bread using slightly different amounts of flour or water. The result changes, still bread, yet quietly different. Some scientists wonder whether other universes, if they exist, might possess different values for the basic properties that shape stars, galaxies, and matter itself. Perhaps such places would never produce stars. Perhaps they would create entirely unfamiliar forms of structure, or perhaps they would remain forever simple and empty. No one can say. The universe has offered us only one example to study directly. This naturally leads to another gentle idea often called the anthropic principle. The name sounds complicated, but its central thought can be expressed very simply. You find yourself living in a universe capable of supporting observers, because only such a universe allows observers to exist in the first place. Imagine walking through an enormous garden filled with countless kinds of flowers. You notice the blossom where a butterfly has quietly landed. Not because it is the only flower, but because it is one where life has found a place to rest. The idea does not explain why the garden exists. It merely reminds us that our perspective is shaped by the simple fact that we are here to experience it. From time to time, another possibility quietly enters popular imagination. Some have wondered whether reality itself might resemble an unimaginably sophisticated simulation. It is an intriguing thought experiment, a way of asking questions about perception, consciousness, and the nature of reality itself. Yet at present, it remains philosophy rather than established science. There is no observation that confirms it, nor is there one that completely rules it out. Like many profound questions, it rests peacefully among ideas that invite reflection more than certainty. Perhaps that is exactly where it belongs. As your journey approaches the farthest horizon, certainty itself begins to soften. The farther you travel, the more the universe gently teaches humility. Not every question receives an answer. Not every mystery asks to be solved today. Some simply encourage us to keep looking with quiet curiosity. There is something deeply comforting in that. A child standing beside the sea does not become disappointed, because the ocean extends beyond the horizon. The distant water is part of what makes the sea so beautiful. The unseen does not diminish wonder. It quietly deepens it. And perhaps somewhere beyond every horizon we can ever observe, beyond every possible bubble of space, beyond every question that patiently waits unanswered, time itself continues carrying the universe toward a future so unimaginably distant that even the brightest stars will one day fall silent. For billions of years, the universe has been a place of gentle beginnings. Clouds of gas gathered patiently beneath gravity, new stars awakened inside quiet nurseries, warm light spread across young galaxies, planets slowly formed around newborn suns. Again and again, the same calm story unfolded. Birth, growth, rest, and renewal. It has happened for so long that it almost feels timeless, yet even the universe cannot repeat the same chapter forever. Imagine walking through a peaceful forest in early spring. Everywhere you look, tiny green shoots rise from the earth. Young leaves unfold toward the sunlight. Birdsong fills the morning air. Now imagine returning to that same forest thousands of years later. The great trees still stand. Their branches remain beautiful, but far fewer young saplings appear beneath them. The forest has not disappeared. It has simply grown older. The future of the universe may unfold in much the same quiet way. Even today, stars continue to be born. Across countless galaxies, gentle clouds still gather. Gravity still performs its patient work. But the vast reservoirs of cold gas that once filled the young universe are slowly becoming smaller. Every new generation of stars quietly uses a little more of that precious material. Some of it becomes part of planets. Some remains locked inside long-lived stars. Some is gently scattered back into space, only to be gathered again. The cycle continues. But each turn of the great wheel leaves a little less untouched gas waiting to become something new. Astronomers sometimes call this long chapter of cosmic history the stelliferous era. The name simply means the age of stars. It is the chapter in which we are fortunate enough to live, a time when galaxies still sparkle with countless suns, when warm starlight fills the darkness, when planets orbit peacefully around glowing skies. If the universe were a single long day, this would still be its bright afternoon. As the ages quietly pass, however, something subtle begins to change. Fewer new stars appear. The great nurseries become calmer. The brilliant blue stars, which live only relatively short lives, become increasingly uncommon. Older stars, glowing with softer golden and reddish light, gradually come to dominate the galaxies. Imagine a lively village slowly growing quieter as evening approaches. The streets remain beautiful. The houses still stand. Warm lights continue glowing through familiar windows. There is simply less movement than before. The universe does not become empty. It becomes peaceful. Entire galaxies slowly change their appearance. The brilliant blue light that once marked vigorous star formation begins to fade. Gentler colours remain. Ancient stars continue their patient journeys around galactic centres. The darkness between them grows just a little deeper. It is not a sudden transformation. It unfolds so gradually that no single civilization could ever witness the entire process. Only the universe itself keeps track of such patient time. Eventually, most of the stars still shining will be those that live extraordinarily long lives. Small stars, using their fuel with remarkable care, continue glowing long after their larger companions have disappeared. Their steady light becomes one of the universe's quiet constants, like candles that seem almost unwilling to go out. Meanwhile, many stars that have already completed their lives leave behind quiet remnants. White dwarfs slowly cool through unimaginable ages. They no longer create new light within themselves. Instead, they gently release the warmth stored during their long histories. Imagine lifting a smooth stone from beside a summer campfire. Long after the flames have disappeared, the stone continues holding a little gentle warmth. White dwarfs slowly cool in much the same patient fashion, not over days, not over centuries, but across stretches of time so immense that ordinary history quietly fades into insignificance. Not every object ever becomes a bright star. Some gather just enough material to become warm, but never enough to ignite the steady nuclear fire that powers ordinary stars. These gentle objects are known as brown dwarfs. They spend their extraordinarily long lives quietly glowing with faint heat, before gradually cooling as well. If stars are like great lanterns illuminating the night, brown dwarfs resemble smooth river stones that have quietly absorbed the last warmth of the afternoon sun. Their light has always been gentle. Their fading is gentler still. Slowly, galaxies themselves begin to change. The familiar spiral arms become more difficult to recognize. The bright regions where young stars once formed grow increasingly rare. Many galaxies settle into calmer shapes, populated mostly by aging stars and their quiet remnants. Imagine an old library after sunset. The shelves remain full. Every story still exists. The building itself has not changed. Only the lively footsteps have grown fewer. The future galaxies possess a similar stillness. They are filled with history. Yet little new writing is added to their pages. Astronomers sometimes describe the chapter that follows as the degenerate era. The name may sound unusual, but it carries no sadness. It simply refers to a future in which the universe is largely populated by stellar remnants rather than actively shining young stars. White dwarfs, brown dwarfs, neutron stars, quiet survivors of an earlier age. The great season of starbirth has gently passed. Still, the universe is not lifeless. Gravity continues its patient work. Galaxies slowly drift. Stars quietly orbit. Invisible matter continues shaping enormous structures across space. Time itself never seems hurried. Everything simply becomes quieter. As you drift through this unimaginable future, you begin to notice something comforting. The universe does not fear growing old. It does not resist the passing of ages. It simply changes. As rivers change their courses, forests change their seasons, and oceans change beneath the quiet pull of the moon. There is dignity in that patience. There is beauty in that slow transformation. And as the last generations of ordinary stars gradually complete their long lives, an even quieter chapter patiently approaches. A future in which the darkest objects in the universe, the black holes themselves, become the final keepers of the remaining light before they, too, begin their own almost imperceptible fading. The universe has now grown wonderfully quiet. The bright nurseries where stars were once born have long since fallen still. The great blue stars have disappeared into memory. Even the gentle red stars that patiently illuminated countless worlds have finally completed their long lives. Galaxies continue their slow journeys through space. Yet they have become peaceful places, filled mostly with quiet remnants, that no longer shine as they once did. There is no sadness here, only stillness. Imagine walking through a great city long after everyone has gone home. The buildings remain, the streets still trace familiar paths. The quiet does not feel empty, it feels restful. The future universe carries a similar calm. Time continues flowing. Nothing has stopped. Everything simply moves more gently than before. Among all the ancient objects that remain, black holes quietly become the longest-lasting guardians of the cosmos. They have survived the passing of generations of stars. They have witnessed galaxies slowly changing around them. Patiently, they continue their silent existence. For a long time, people imagined black holes as permanent, perfectly eternal, the final destination from which nothing could ever escape. Yet nature often whispers more subtle stories than our first impressions suggest. Many years ago, the physicist Stephen Hawking proposed a remarkable idea. The invisible boundary surrounding a black hole may not be completely silent forever. Instead, over incomprehensibly long stretches of time, a black hole may very slowly give away tiny amounts of its energy. The process is known as Hawking radiation. The name may sound technical. The image, however, can remain beautifully simple. Imagine a block of ice resting beneath a quiet winter sky. No dramatic melting takes place. No flowing streams appear. Yet, almost too slowly to notice, the ice gradually becomes a little smaller, day after day, season after season. The change is almost impossible to witness moment by moment. Only after an immense passage of time does the difference become clear. A black hole may experience something quietly similar, not because anything dramatic happens inside it, but because nature itself appears to allow an almost unimaginably gentle release of energy. No observer could comfortably sit and watch this happen. Even the smallest black holes known today would require lengths of time so vast that entire chapters of cosmic history would pass before the change became noticeable. Patience itself seems too hurried for such a process. Yet the universe possesses all the time it could ever need. Little by little, almost beyond imagination, the black hole becomes slightly smaller, then slightly smaller still. No fireworks, no sudden ending. Only an endless series of quiet moments, each one nearly identical to the last. If the universe could breathe, this would resemble the slowest exhale imaginable. During these unimaginable ages, another quiet possibility sometimes enters scientific discussions. Some theories suggest that even the tiny building blocks of ordinary matter may not last forever. This idea is known as proton decay. No one has ever observed it directly. Indeed, it may never happen at all. For now, it remains an open question rather than an established fact. But if nature truly behaves this way, then even the most familiar matter could eventually fade across stretches of time beyond ordinary comprehension. There is no need to picture individual particles disappearing. Instead, imagine an old stone wall standing peacefully in a quiet field. Century after century, tiny grains slowly loosen. A little dust returns to the earth. The wall remains recognizable for an extraordinarily long time, yet no change is ever completely absent. Nature often prefers patience over urgency. Whether proton decay ultimately proves true or not, the deeper lesson remains the same. The universe continues changing, even when those changes become almost impossible to notice. Eventually, the great black holes themselves continue their own patient fading. The enormous giants once found at the centers of galaxies outlast nearly everything else. For ages beyond imagination, they quietly persist. Then, slowly, even they begin surrendering the last traces of their stored energy. Astronomers sometimes call this chapter the black hole era. It is a universe where black holes become the dominant visible actors upon an almost empty stage. Not because they are active, but because nearly everything else has already completed its story. Yet even this era does not last forever. As one immeasurably long age follows another, the final black holes gradually complete their own gentle fading. Some descriptions of these distant futures speak of a span called a googol years. The phrase simply refers to a length of time so unimaginably vast that ordinary numbers quietly lose their meaning. It is not a number meant to be counted. It is a reminder that the universe measures time on scales far beyond everyday experience. After such extraordinary ages, astronomers imagine the beginning of what is often called the Dark Era. The name sounds dramatic. The reality is remarkably peaceful. Imagine sitting beside a quiet lake late at night. One by one, the reflections of distant lights disappear as homes gently turn off their lamps. Eventually, the lake reflects only the darkness of the open sky. The water remains calm. The silence deepens. Nothing frightening has arrived. There is simply less light than before. The dark era may resemble that quiet lake. Almost no stars remain. Almost no glowing remnants continue shining. Only extraordinary stillness stretches across space. Time continues. Space continues. The quiet itself becomes the dominant feature of existence. As you drift through this final darkness, you may notice something unexpected. The universe has never hurried. From the first newborn stars to the final fading black holes, every chapter unfolded with remarkable patience. Nothing rushed toward its ending. Nothing struggled against time. Each moment simply became the next. Perhaps there is comfort in that gentle rhythm. The universe does not fear silence. It carries silence with extraordinary grace. And now, as nearly all light has softly faded into memory, you find yourself floating in the calmest place imaginable, where time still moves, the cosmos still quietly exists, and the story you have followed from living planets to sleeping galaxies rests peacefully within an endless, gentle darkness. For a long while now, you have been drifting, not toward any destination, not searching for a final answer, only moving gently through one quiet story after another, allowing the universe to unfold at its own patient pace. There has never been anything to solve, nothing to finish, only moments to notice. And now, as this long journey slowly comes to its peaceful end, you find yourself floating somewhere beyond the urgency of time. The stars no longer rush past. The galaxies no longer seem impossibly distant. Everything has become calm enough to simply remember. Do you remember where it all began? Not in some distant galaxy, not beside an ancient black hole, but on a small blue world wrapped in soft clouds, a place where oceans quietly breathe against patient shores, where forests sway beneath gentle winds, where every person who has ever looked upward has shared the same sky. Earth never needed to be the largest place in the universe. It only needed to be home. From there, your curiosity carried you outward. You wandered among distant planets, unlike anything found beneath our own skies. Some glowed with rivers of molten rock. Some rested beneath endless oceans hidden beneath frozen surfaces. Others drifted alone through the darkness without the warmth of any nearby star. Each one reminded you that nature rarely repeats itself exactly. The universe has always been wonderfully creative, yet even the strangest worlds never felt frightening. They simply waited quietly, each carrying a different version of possibility. Then your journey carried you into the patient lives of stars. You watched gentle clouds gather beneath gravity. Tiny newborn suns quietly awakened inside vast nurseries of gas and dust. You followed ordinary stars through lives that lasted billions of years. You stood beside gentle red giants. You admired brilliant supergiants whose immense light crossed unimaginable distances. Even when their lives ended, they did so by giving something back. Their final gifts became the elements from which future stars, planets, oceans, mountains, and living creatures would one day quietly grow. You learned that endings are often another form of beginning. Then came the silent black holes. Once they seemed mysterious, perhaps even frightening. But as you drifted closer, they became something different. Not monsters hiding in darkness, simply places where gravity gathered with extraordinary patience. You watched glowing rivers of light circle their invisible boundaries. You learned that even these ancient objects are not completely separate from change. Given enough time, even they slowly surrender their remaining energy. Nothing in the universe insists upon lasting forever. Not because forever is impossible, but because change itself is one of nature's gentlest habits. From there, your view expanded once more. The Milky Way unfolded around you like a quiet river of stars. You drifted beyond its graceful spiral arms into the company of countless other galaxies. Some were elegant spirals, others resembled glowing lanterns. Some carried delicate rings, others stretched long trails of light behind them like silent jellyfish drifting through a tranquil sea. Then even those galaxies became only tiny pieces within something larger. Clusters gathered into immense families. The great rivers of galaxies quietly revealed themselves as delicate threads within the cosmic web. The universe no longer resembled scattered islands. It became a vast tapestry, every thread gently woven through the darkness by invisible gravity. And then, almost without noticing, your attention shifted toward everything that could not easily be seen. The hidden matter quietly shaping galaxies. The mysterious influence gently encouraging space itself to expand. The unanswered questions patiently waiting beyond every new discovery. You discovered that science is not a collection of finished answers. It is a conversation, one that has continued for generations, and one that will continue long after tonight. Perhaps that is one of the most comforting thoughts of all. No one is expected to understand everything. Wonder is enough. Curiosity is enough. Quiet observation is enough. Beyond the visible horizon, your imagination wandered softly through possibilities. Perhaps there are regions forever beyond our view. Perhaps countless other universes quietly exist beyond every horizon we can ever observe. Perhaps reality is even stranger than language can comfortably describe. Or perhaps the universe is simpler than we sometimes imagine. For now, the wisest answer remains beautifully peaceful. We simply do not know. And somehow that uncertainty has never made the universe feel smaller. It has only made it feel deeper. Finally, together, you drifted into the farthest future. The stars gradually completed their patient lives. Galaxies settled into extraordinary silence. Even the oldest black holes slowly released the last whispers of their energy. Darkness itself became calm rather than empty. Time continued. The universe continued. Its story never truly stopped. It simply became quieter. And now, you find yourself here. Not at the end of everything, only at the end of tonight's gentle journey. The universe does not ask you to remember every galaxy, every star, every quiet mystery. It asks only that you notice, if only for a little while, how beautifully patient everything has always been. Perhaps that patience has quietly become part of you as well. Your breathing has slowed, your thoughts have softened. The weight of the day has gradually become lighter. There is nowhere else you need to travel tonight. Nothing left to understand before sleep arrives. The stars will continue their patient journeys without asking for your attention. The galaxies will keep drifting through the darkness. Invisible gravity will continue weaving its delicate threads across the cosmos. The quiet future will continue unfolding one gentle moment after another. Everything is already exactly where it needs to be, and so our journey drifts quietly to its end. Whether you're still listening beneath the gentle glow of your screen, or already floating somewhere between dreams and distant stars, thank you for travelling here tonight, through silent galaxies, ancient particles, quiet oceans beneath frozen worlds, patient stars, invisible gravity, and the gentle laws that softly hold the universe together. If this wandering has brought you even a little peace, you're warmly welcome to return whenever you need another quiet night beneath the cosmos. For now, simply rest. There is nothing more to do, nothing more to solve. You are safe. You are warm. You can let your thoughts drift as softly as starlight crossing the endless night. Even while you sleep, the stars will keep burning where stars still remain. The galaxies will keep drifting through the quiet ocean of space. The universe will continue its slow and patient story. And somewhere within that endless story, you have always belonged.